Hello students, today we will discuss some examples based upon law of equipartition of energy. Means how a gaseous molecule contributes its energy according to its movement in different directions. Examples of law of equipartition of energy. At first we will take an example of molecule of organ gas. A molecule of organ gas is a monatomic atom. It has three translatory degree of freedom. So it can contribute the energy equals to its energy contribution will be equals to 3 multiply half kBT. 3 multiply half kBT, where T is the temperature of gas molecule, Kb the Boltzmann constant. That we can write 3 by 2 kBT. Now consider another example of a gaseous molecule such as oxygen and nitrogen, where both of the molecules are composed of two individual atoms. Oxygen atom has the molecule of oxygen has two oxygen atom in it. Similarly, the molecule of nitrogen has two atoms of nitrogen in it. In that case, we can take another example for diatomic gas molecules, molecule of oxygen gas. It is a diatomic molecule and it has three translatory degree of freedom because it can move in any of the three-dimensional direction in a straight line, and also it has two rotational degree of motion, rotational degree of freedom. Why it has two rotational degree of freedom? The molecule of oxygen atom is such that it can rotate on its own axis in two different directions. Say, see in the given diagram, the oxygen molecule having two atoms of the oxygen making a bond with each other and rotating about an axis. In first case, in figure number 1, the oxygen molecule can rotate about a vertical axis, and in the second figure, the oxygen molecule can rotate about an horizontal axis. So it will have two directions of circular motion, or you can say it can execute circular motion in two planes. In that case, it will have two rotational degree of freedom and it will contribute the same amount of kinetic energy with respect to its rotation in a plane. So its complete contribution to its kinetic energy will be equals to its kinetic energy equals to 3 translated degree of freedom contribution plus the kinetic energy due to 2 rotational degree of freedom. Here the same thing is there, that a single rotational degree of freedom provides the same amount of kinetic energy, half kBT. It means the total contribution of kinetic energy of the oxygen molecule can be given as follows. So contribution of kinetic energy of oxygen molecule will be equals to 3 multiply half kBt. That is because of the translatory degree of freedom plus 2 multiply half kBt. That is because of the rotational degree of freedom. So its total contribution of energy will be provided as 5 by 2 kBt. Now we can consider another molecule which can have a degree of freedom different from the translated degree of freedom or the rotational degree of freedom. That will be its degree of freedom due to its oscillatory motion. So if a gas molecule is free to oscillate or vibrate with respect to its mean position, it contributes mechanical energy relevant to its vibratory motion as 2 multiply half kVt. This 2 multiply half kVt contribution of energy is only because of its vibration with respect to its mean position. So the same gas molecule which has a translation degree of freedom, a rotational degree of freedom, can also have a vibrational or oscillatory degree of freedom. And according to oscillatory or vibratory degree of freedom, it can contribute 2 multiply half kVt of energy. This is the contribution of the molecule's energy due to its potential energy plus its kinetic energy at any moment of its vibratory motion. So in this way we have discussed that any of the gas molecule can has different type of degree of freedom relevant to its type of motion, whether it is in translatory motion or it is in translatory plus rotatory motion, or whether it is in translatory plus rotatory plus vibratory motion. So according to its different types of motion, its energy contribution regarding that type of motion will be added, and finally its complete energy contribution to its motion can be calculated as we have discussed here. So that's all for today. We will continue the next topic next time. Till then, good day.